try to use 3 data sets. Actually, everyone knows that the DARPA 99 is the old data set. However, we still try to use to do some concept proof. And then we try to use Acer data set collected by the Security Operations Center. This is contain 300,000 alert data, and with the ground truth. The ground truth is labeled by the experts for the Acer company. And then we also try to use another kind of data set is a PKDD 07. PKDD 07 is a web application, web text data set. I just mentioned that it has eight classes. It's a multi-class classification problem, and 7 is a text and 1 is benign. Okay, we just use these 2 metrics to evaluate our method. Especially, I want to say that the positive means the attacks. The true means the attacks. We think it's a text. The first series experiment is the sensitivity analysis. And there has 3 data sets plot, and the axis is the correlation window size. We select from the 2 to 11, and the red line is the error rate, the green line is the precision, blue line is the result. What we want to say in the 3 figures that our SBAD can robust to the different correlation window size. Okay. And then we do some comparison with the migrant and the all pairs. And you can see this is wrong spelling. And migrant have a significant, when we use the SBAD, all pairs it perform significantly better than the migrant content relations. Okay. And then we we do the comparison with the other baseline approach. So you can see that we have a larger ROC curve coverage than other methods. For example, it's performed where the BAD is SBAD plus the K-means neighbor, and perform well than just use the decision trees algorithm. Also, in the PKDD dataset, we have also a large coverage. So, okay, this is effectiveness analysis. And then we compare, because the PKDD dataset has the best result at that year. So we compare with their result. Actually, you can see the triangles here is the PKDD based result in 07. And our method is at here, and we have a better precision and recall rate than the PKDD based result. Actually, their method try to use the rule-based method approach to identify the text. So, okay, we do not need a lot of expert involved. Okay, finally, we want to visualize that we just do the decision that it makes sense or not. And okay, at this figure I just mentioned, but I will detail these figures. That there has 8 classes, and you can see the processor has far away from the other group. Actually, in this dataset, the processor is the easily classified classes because cross-script including some spatial symbols. Want to skip for example, the script checking function. So it's not like this one. And actually, we do not is in path traversal. The path traversal has many slash. So it was not. It is a little difficult to differentiate between the LDAP injection. However, if we zoom in, actually these 2Ds also can separate them. Okay. Another example is from the ASA dataset, and actually the text will be grouped at here, and so we can clear to know which area must be the hot area. and we will do the final inspection. Okay, I turn to the conclusion for this work. And in this work, we propose a fully implemented method for event sequence analysis. And now this method has proposed to the ISP provider to do some testing. And actually, it's easy to plug in the current IDS system because we just analyze the log of the IDS system and without doing any configuration. Okay, you can see the robust automatic and we can visualize the result. Okay, thanks. And if you want the data set and the code, you can free to contact me. Thank you.
Thank you. Any questions?
Yeah. So to understand it right, so you're constructing this graph and then you're building a sequence out of it and you're sequence modularity?
Yes. I use the sequence construct the graph, and I use the graph to describe the another sequence to measure how this model can describe this sequence, and we found the distances.
Okay. So could you use some usual graph similarity measures for that, or do you have to construct a similarity with sequence afterwards?
Construct sequence afterwards.
So, but is there any reason for example, not using graph terms or something like that?
Actually, the graph is a Markov model. Yeah, it's a state transition. So actually, when we construct the graph, maybe we lose some structural information. So it is not suitable for directly compare the graph to graph.
Okay.
So yeah.
So you mean that when you have a new sequence, you just put it in all the graphs and see where it matches, right?
Yes. Yes.
So when you construct a graph, its graph is composed of a set of graphs with two nodes. With a set of, so every graph has one pair or has many pairs?
The graph has, you mean the inside the graph, the node pairs?
Yeah.
Many pairs.
Many pairs.
Many pairs.
I'm not sure if I understood correctly when you mentioned that your approach has similar performance for all correlation windows.
All pairs correlation windows? So I mentioned it. Okay, so we do the all pairs, then we hope to reduce the impact of this kind of patterns. That pattern is inserted in this position. So all pairs means we count the all pairs under the correlation windows.
Yeah, I'm asking about the size of the correlation window.
The size must defined by the heuristics. However, we just made analysis that is relatively stable for different window size.
For any size?
Yeah. We just analysis to 2 to 11.
And it's similar?
Yeah. Yeah, it's slightly different.
So you have evaluated mostly in data sets of wired networks, I understand.
Yeah, wired network.
Would you consider as a future work to check its performance, to evaluate it in a wireless network, for example?
Yes, but yeah, maybe I can.
Which indications do you think will be appropriate here?
Yeah. Maybe. So yeah. Actually, you just asked the correlation window size identifications. Actually, you can see these have different channel. The Acer and the DARPA 99, the recall will increase when you enlarge your correlation window size. However, in the PKDD analysis, because there has 8 classes of the text, 8 classes. So analysis, database related web attacks, the larger the window size, the precision and the recall will decay. Another one is for the some command based is would increase because the noise is different in this data.
One final one. So here you're using pairs. You could have used single symbols, or you could have used three tuples, or whatever, right? Or you could have gone to a variable order case. So what are the results with, let's say, single symbols?
Single symbol?
Yeah. Not worse.
Okay. What is single?
So right now you make graphs which are basically it's subgraphing the graph is two pairs.
Yes.
So you could go with one symbol, or you could go 3 or 4.
I'm not doing that yet.
Okay.
Yeah, I can try.
But you're aware of variable order markup models?
Yes.
Okay.
Yes. Actually, we use hidden markup model. However, there's a lot of another additional work because we need to define the several parameters we need to estimation. We use EM is not very well.
Yeah.
So which I think markup model is the appropriate. It's easy and simple.
Thank you.
Okay, thank you very much.